So Xu and Tenenbaum in 2007 wanted to see if children have the kind of response that we see in Bayesian learners to suspicious coincidences. That is, when they're giving data that are compatible with multiple hypotheses about word meaning, do they make the kind of generalization that a Bayesian learner would make? So to be more specific, if they're given a couple of different hypotheses to choose from, a subordinate meaning, say Dalmatian, which would be the least general, versus a basic level meaning like dog, versus a superordinate or most general level like animal, and they're given data that are compatible with any of these three hypotheses, which one do they use? Because the Bayesian learner is going to prefer the most specific one due to that likelihood calculation we saw in the previous video. So here's how their experiment went. They tested 3 and 4-year-old children, and the first part of the task, children were presented with 3 examples of a novel word like fep or blick or dax, which are reasonable English made-up words, right? During training, they would say something like, this is a fep, or this is a dax, or this is a blick. So we're just going to continue with the fep example. But the idea is there were 3 classes of stimuli of possible reference: vegetables, vehicles, and animals. And this is actually a figure from their paper, which is sadly in grayscale, but again, these were likely in color for the kids, right? And so there were subordinate, basic, and superordinate reference. So for the vegetables, the subordinate would be a green pepper versus a basic would just be a pepper versus a superordinate would be a vegetable. For the vehicles, you would have subordinate being yellow trucks, the basic a truck, superordinate any kind of vehicle. And for the animals, you would have subordinate being a terrier, the basic being a dog, the superordinate being any kind of animal. Okay, so then there were 4 conditions for the different types of learning experiences this 3 and 4-year-old children could have. So first was the one example condition. We just show you the same object and we labeled it 3 times with this novel word. So that would be like showing you, for example, 3 different instances of the very same Dalmatian and saying, this is a fep, right? You're like, okay, I see the same fep 3 times. Fantastic. What do I make of that? Versus 3 subordinate example condition, where you get 3 examples of different subordinate items and that same label. So this would be seeing like 3 different Dalmatians labeled feps. Then we have 3 basic levels, right? So you get 3 basic level objects labeled 3 times with this object, so 3 different, say, dogs labeled as feps. And then finally 3 superordinate examples. So you get objects from that, that biggest generalization of class, like 3 different animals labeled fep. Okay. So here are your different experiences. This is the learning part. Now during the generalization part, we see what you have learned. And the way that these kids were tested was help Mr. Frog identify only things that are feps, say, or blicks or daxes, depending on the training condition. But let's go with feps. Identify only things that are feps from a set of new objects, right? So this is showing how far you are willing to generalize this label. What hypothesis does this correspond to? And there were 3 kinds of matches that were available. So you would have the subordinate matches, which were the least general, right? So you would have, just green peppers or just yellow trucks or just terriers. You would have the basic level ones, which would be peppers and trucks and dogs. And you would have the superordinate ones, which would be vegetables or vehicles or animals. And you say, okay, find me all the other feps there are here, right? And so let's see what they did. So when children heard a single example 3 times, that is the very same Dalmatian, say, called a fep, they readily said, okay, all the other Dalmatians are feps too, but they're less likely to generalize to all other dogs and even to all other animals, which is these 3 bars we see on the right-hand side here. So the tallest bar is the subordinate, in this case Dalmatian from this example. The lighter gray bar is the dog, and the lightest gray bar is animal. And you can see that the tallest one really is that subordinate class. I think fep means Dalmatian. So this shows that children are fairly conservative in their generalization behavior, but that's really when you just see the same thing labeled 3 times. What happens if you see 3 different Dalmatians, say, labeled as feps? So when children had only subordinate examples, then they really strongly said, yeah, okay, this is Dalmatians. Fep is Dalmatians. I have a tall black bar, but then really almost nothing in terms of generalizing to other dogs or certainly to other animals. So they're still pretty conservative. This is exactly what we would expect from a Bayesian learner. They're sensitive to the suspicious coincidence, and they choose the least general hypothesis compatible with the data. So now what happens if you get basic level examples, so you get 3 different dogs labeled as FEPs, well then they're happy to call all the other Dalmatians FEPs, so that's our black bar. They're also happy to call other dogs FEPs, that's our basic level lighter gray bar. But they're not really willing to go beyond that and say all other animals are FEPs. And so this is sensitive to that suspicious coincidence. You're choosing the least general hypothesis that's compatible with these data. So what happens when you actually finally get a whole bunch of different animals labeled FEP? Well, then they're like, okay, well, all Dalmatians are FEPs and all dogs and mostly other animals too. You can see that last gray bar there in the orange isn't as high as the other ones, and we'll talk about reasons for that later, but suffice it to say they definitely generalized more to other animals for the 3 superordinate examples in the training period than any of the other conditions. So they're clearly willing to extend that generalization further than they did before. So this again shows they're sensitive to the suspicious coincidence, though they're still maybe a little uncertain how far to extend the generalization. And so when we see children's behavior, right, this is what we see when we actually test 3- and 4-year-old children. And then, you know what, if you test Bayesian model the very same data, you get a very similar pattern. So we're seeing both our kids and our Bayesian model able to do this kind of suspicious coincidence calculation.